Bismillahirrahmanirrahim. The convolution integral is an important integral that we evaluate in electrical engineering. Convolution integral is used. It is used to determine response of a system. Response y of t of a system to an input x of t if we know the system's impulse response. H of t, right? So this integral is defined something like this: y of t, this is the output, minus infinity to plus infinity, x of lambda, lambda is dummy variable here, and x is the input, and h t minus lambda d lambda, lambda is the dummy variable, h is the impulse response. So when convolved, when input is convolved with the impulse response, we get the system's response to this input x. And this integral is also, this convolution is also represented as x of t. This is the convolution symbol convolved with h of t, right? So lambda is a dummy variable here, and this convolution integral is commutative. Right? So y of t is equal to x of t convolved with t, and that is also equal to h of t convolved with x of t, and also follows distributive and associative properties. Right, and one particular property of the Laplace of this convolution integral with respect to the Laplace transform is that if the Laplace transform of a function f1 of t is equal to, and the Laplace transform of another function f2 of t is equal to f2 of s, then f1 of s multiplied by f2 of s is equal to the Laplace transform of the convolution of f1t and f2t. This is an important property. So with the help of this property, instead of evaluating the convolution integral, what we can do is we can find out the Laplace transform of f1 of t and f2 of t, then multiply them together. And then to find out the convolution of f1 of t and f2 of t, we can find out the inverse Laplace transform of this product. So the convolution of f1 of t and f2 of t is equal to the inverse Laplace transform of f1 of s multiplied with f2 of s, right? So again, we can find out the Laplace transform of f1 of t and that of f2 of t. So we multiply the Laplace transforms of both these functions and then find out the inverse Laplace transform of the product to find out the convolution of f1t and f2t. Instead of evaluating the integral, we can use this formula to find out the Laplace, the convolution of f1t and f2t using the Laplace transform.